Chapter 12 review, starting with number 2. Let me find the page. Okay, found it. Number 2. For women in Haynes 5, the relationship between height and income can be summarized as follows. What is the regression equation? So we have an x bar of 64 with an SDX of 2.5, and our y bar is 21,000 with an SDY of 20,000, and R is about 0.2, which is a terrible regression, but whatever. So my data looks like this, and we want the regression equation that fits that data. So I need the slope. Slope is rise over run. So rise over run, and the rise is going to be the SDY times R, and the run is going to be the SDX. So I take 21,000, times that by 0.2, and divide it by 2.5. And I get the number 1680. What does 1680 tell us? It's the slope. Can you put it in context to the story? So down here we have, is it age? Oh, height. So down here is height, and up here is income. What does 1680 mean? For every 1 inch increase in height, there is an equivalent $1,680 increase in income. So apparently, the taller you are, the more money you make. Okay, now, so the slope is 1680. Now I just need the y-intercept. Well, my point of averages is 64, 21,000. And I'm going to use y equals mx plus b. So the easiest way to solve for that is put your m in, and then take your point of averages and plug that in, and then solve for b. So we end up with 21,000 equals 1680 times 64 plus b. So I take 21,000 and I subtract off 1680 times 64. And I get that number, which is the y-intercept, which actually is way below the x-axis. So the equation is 1680 x minus 10,000 or 105,420. Why is this equation so useful? Why do we want to find the equation? Now it's really easy to predict y values given an x value. Just plug it in. Instead of the old find the distance, turn it into a z-score, multiply it by the SD, convert it into y value, all of that stuff. We don't have to do that anymore. We can just plug it in. Can I take an income and predict a woman's height using this equation? No, you have to find the other equation in order to do it. Yeah, we could. How would you do the other equation? Yeah, you definitely can. The other equation is going to be x equals my plus b, and the slope, you're going to switch the slope by flipping those, and then it's just the same process. But instead of finding the y-intercept, you find the x-intercept. Okay. Number 3. The regression equation for men in Haynes 5 is 0.0267x plus 65.2. So this is a height and weight equation. Height is measured in inches and weight in pounds. If someone puts on 20 pounds, will he get taller by 20 pounds times 0.0267 inches per pound is about 5 inches? Yes or no? Right, that's what it's asking. If you gain 20 pounds, are you expected to grow half an inch? No. So this equation does not mean, it does not measure if you grow, sorry, if you get heavier, then you get taller. But it says heavier people are, on average, taller. Does that make sense? So this equation does not measure change. It just measures people in their current state. Does that make sense? So if we were doing age and income, and it looked like the older you were, the more you made, it would be safe to say if you get older, you're probably going to make more money because you usually get raises in your job. Right? But in this case, gaining weight doesn't make you any taller. So, no. Oh, I erased the numbers. What's the next one? 5? A study is made of working couples. The regression equation is 0.1667 x plus 24,000 Another investigator solves this equation for husband's income and gets, so this is husband's income and this is wife's income, and somebody says, oh, I want the other equation. So I'm going to subtract 24,000 is equal to 0.1667x divided by 0.1667. That cancels. Divide this by 0.1667. And this inverted is 6. So we get 6y minus 144,000 equals x. True or false? The second investigator has found the regression equation for predicting husband's income from wife's income. False. It's not that easy. Well, and they will have different slopes, right? But the R value is going to mess things up. You can't flip it like this. Certainly they're going to have different slopes, but this is definitely not going to be the appropriate equation. So, for instance, if you want to compute anything, husband's income is 54,000 with an SD of 39. Wife's income is 33,000 with an SD of 26 with an R value of 0.25. So let's calculate the slope of the other equation. This slope is simply SDY times R over SDX. And the other slope comes out as 6, and let's try it. SDX times R over SDY, and that's going to be 39,000 times 0.25 divided by 26,000, and that's the slope of the other equation. So this is way off. Interestingly enough, when you invert a line, you actually reflect it across the line y equals x. So this is just kind of a side note. So let's say I have that first equation. What we did to invert it, you take the 45-degree line, and then inverting it's going to look like that. Okay? But if we do the y on x line, so here's our football, and here's our SD line. The other equation is actually a reflection across the SD line. Whoa, that's not right. Sorry. So The two regression lines are reflected across the SD line, not the line y equals x. Okay, what's next? Number 8, an investigator wants to use a straight line to predict IQs from lead levels in the blood for a representative group of children aged 5 to 9. There is a weak positive association in the data, which means which apparently means the more lead you have in your blood, the higher your IQ, right? Is that what there's a weak positive association? True or false? Explain. He can use many different lines. Nope, there's only one. If you're doing linear, there's only one. Okay? He has to use the regression line. I would say true. That is the only one that works. Only the regression line has an RMS error. This is a weird question. I don't really know what that means, because every column has an RMS error. So I would say false. Any line he uses will have an RMS error. That's true, but it won't be a valuable number. Among all lines, the regression line has the smallest RMS error, and that is also true. Wow. Not sure why they picked that one. Okay, 9. In a large study that's hypothetical of the relationship between parental income and IQs of their children, the following results were obtained. It was found that the points on this graph followed a straight line very closely. The slope of this line in IQ points per dollar would be about, so you're going to take SDY times R over SDX. So 15 times 0.5 over 45,000. And turn it into a fraction. And 1 over 6,000. Which would be in IQ points per dollar. So for every dollar your parents make, you gain 1/6,000th of an IQ point. Okay. Explain briefly. That's my explanation right there. 10. One child in the study referred to in exercise 9 had an IQ of 110, but the information about his parents' income was lost. At $150,000, the height of the line plotted in exercise 9 corresponds to an IQ of 110. Is $150,000 a good estimate for the parents' income? Yes or no? And the answer is no. Here's why. So we have this football here, and this is $90,000, and this is 100 IQ. Okay, so we know that this particular child has an IQ of 110. Okay, so that kid is somewhere in this column here. Okay, but we don't know how much their parents made. So let's use the regression equation that we have, 1 over 6,000 x plus, I don't know what it is, we didn't figure it out. But if a person has parents who make $150,000, and we go up to the regression equation right there, that point is 150K, comma 110. Is 110 a good prediction? Or sorry, is 150,000 a good prediction for that person? No. The best prediction for this person is going to be the middle of the row. Right? How do we get that number? We use the other regression equation. So is it expected to be too high or too low? Let's see how carefully I drew my picture. So my SD line is going to look like this. Yeah, I think it's going to be too low. Or 150,000 is too high, I guess. 11. A congressional report is discussing the relationship between income of parents and education attainment of their daughters. Data are from a sample of family with daughters, average income, average. The regression line for predicting daughters' education is 0.0000925 years per dollar, with the y-intercept of 10.3. Is anything wrong? You see anything wrong with this? So the regression equation for predicting education from parental income is 0.0000925 times the income plus 10.3. Do you see a problem? What about the y-intercept? What's wrong with the y-intercept? It should be a little lower than the average because the correlation is positive. But if you have no income, then you're predicted to have 10.3 years of schooling, right? Probably not very accurate. So I would say something is wrong because that y-intercept is messed up. Now, it might be that the data isn't linear. It might be that there was a mistake in the calculations. The average income was 12.7, or sorry, the average educational attainment is 12.7, and the y-intercept is 10.3. So something's not right. Okay, 12. Many epidemiologists think that a high level of salt in the diet causes high blood pressure. Intersalt is often cited to support this view. Intersalt was a large study done at 52 centers in 32 countries. Each center recruited 200 subjects in 8 age and sex group. Salt intake was measured as well as blood pressure and several possible confounding variables. After adjusting for age, sex, and other confounding variables, the authors found a significant association between high salt intake and high blood pressure. However, a more detailed analysis showed that in 25 of the centers, there was a positive association between blood pressure and salt. In the other 27, the association was negative. Do the data support the theory that high levels of salt cause high blood pressure? What do you think? Well, there is one big problem. First off, 25 of the centers had one conclusion, and 27 of the centers had the opposite conclusion. So that's a little bit problematic, but what's the biggest problem? So let me read that again. Do the data support the theory that high levels of salt cause high blood pressure? Reagan shaking her head. Why? Do these studies show that adding salt to your diet will increase your blood pressure? What's that? This is just an observation. They did not do an experiment. They just went around and measured salt and blood pressure. They didn't say, you guys add salt to your diet and you don't, and then we'll see what happens. So this is just an observational study, which means we can show association. We cannot say causation. All right.